Okay, so today we're going to visualize fractions, and I think you'll be surprised at how often you actually use fractions in your everyday life. You just probably don't realize you're doing it. Okay, so oftentimes we use pizza or we use pie or something like that. It doesn't necessarily have to be a circular figure that we're looking at fractions with, but these are the most commonly used ones. So if you check that out, you've got half of a pizza right here. Here's your other half. Two halves make one whole. If you look at this second pizza right here, you've got quarter of a pizza right there because you split it up into 4 pieces, and one of those 4 pieces is 1/4. If you took 2/4 of those, you actually have 1/2. So 2/4 is equal to 1/2. We'll get more into this a little bit later. But if you look at this last one, you've got this one cut up into 12 slices. And how many of these slices does it take to make up half of a pizza? There's 1, 2, 3, 4, 5, 6. So 6/12 is also equal to 1/2. Okay, these are some important vocabulary words. So if you have to hit pause and read through this, that is what I would recommend that you do. So with a fraction, we typically write them A over B. A lot of people will write their fractions side by side like this. I don't recommend that, especially if you're going to take any higher levels of math. Please get out of this habit right here. Don't write your fractions side by side. It gets very, very confusing later. So just start the habit now of writing your fractions stacked like that one. The number on top is called your numerator, and the number on bottom is your denominator. How I used to remember this years ago is that denominator kind of sounds like the word demon, and demons are in hell, which is down below. So that's how I used to remember this, is that denominator kind of sounded like demons. All right, so we are going to talk about just the shaded regions of these. Like the top one is a circle, so we've got this circle cut into how many slices? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 total slices. The number on bottom is your total. The number on top is the shaded region. So we've got 1, 2, 3, 4, 5. 5 over 8 is our shaded region here. Okay, so let's look at this square. We've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. That number 9 goes on bottom. The shaded region goes on top, and there's 2 of those. Okay, so it says here to shade 3/4 of the circle. In order to shade 3/4, you have to try to cut this into 4 equal parts. So I'm not going to come along with a ruler or anything like that, but just do your best to try to shade, or cut it, into equal as you can, equal parts. I did the best I could without measuring anything. So now they want me to shade 3/4 of this. So I'm going to shade 3 out of the 4 pieces. And you don't have to go from edge to edge, but just do your best to shade those areas. Okay, so that right there represents 3/4 of the circle. This is a really, really important concept right here. This says that any number, with the exception of 0, divided by itself is 1. So if I have a pizza and I'm cutting it into 6 slices, and I eat 6 out of 6, then I just ate 1 whole pizza. If I have a pizza and I'm cutting it into 12 slices, and I eat 12 out of 12 slices of pizza, then I ate 1 whole pizza. So any number divided by itself is 1. Okay, so it says here to use fraction circles to make wholes using the following pieces. So if I'm going to take 3 halves here, 3 halves, that means that out of a circle that is cut into half, 2 pieces, I want 3 of those. So I want, here's 1 piece, here's 2 piece, and then here's a 3rd piece. So how much do I actually have? I have 3, and each one is cut into 2, okay? But that's the same thing as 1 whole pie and 1/2 of another. The quick way to do this math is you can ask yourself, 2 will go into 3 how many times without going over? And that answer is 1. It'll go in 1 time, but it has 1 remainder left over, and that's that numerator. The denominator does not change. Okay, so on the part B of this one, it says 8/5. That is written like this, 8 out of 5. So that means each of your circles are cut into 5 pieces, but we want 8 slices. So here's 1, here's 2, here's 3, 4, 5, 6, 7, and 8. So 8/5 means I have 1 entire pie or pizza or whatever you're looking at, plus I have 3/5 of another one. The fast way to do that math is 5 will go into 8 without going over 1 time. You have a remainder of 3, that's your numerator. 5 is your denominator. All right, for part C, we have 7/3. So that means that we want, oops, hang on, I need 1 more of these. Okay, there we go. Now we have 1 more. So 7/3 means that I've got 3 on the bottom and I want 7 pieces. So 3 is how much each pie is cut into. Each pie is cut into 3 pieces, and I want 7 pieces. So here's 1, 2, 3, 4, 5, 6, and then there's my 7th piece. So if I'm talking about giving kids pizza at a party, and I give each pizza's cut into thirds, and I've got 7 kids that are getting these slices, then how many total pizzas did I use up? I used up 2 whole pizzas, plus I used up 1/3 of the last pizza. Does that make sense? So 3 will go into 7 2 times, and I had 1 remainder, that's your numerator, and then 3 is always going to be your denominator if we're cutting into thirds. Okay, so this is another page where you may want to pause and read this. Mixed numbers are what I was showing you on the last couple of pages, where we had 3/2 is the same thing as 1 1/2. Not sure if those are the same numbers that we used or not, but 3/2 is called improper fraction. That's where your top number is bigger than your bottom number. A mixed number is where you have your whole units and then your partial next to it. So that's your mixed number. 1 1/2 is a mixed number, and 3/2 is an improper fraction. Okay, so right here it says to name the improper fraction modeled. So we have 1 whole unit colored in, right? So that's 1. And then we have how much of another piece of pie or another pizza or whatever we're talking about here. We have 1 part colored in, and they are cut into 3 parts. So this would be 1 1/3. Incidentally, it also asks you for the mixed number. We just gave you the mixed number. This is your mixed right here. Okay, your improper is 1, 2, 3, 4, and each pie is cut into 3 pieces. So this is your improper right here. Okay, on this page, draw a figure to model 11/8. So that means each of these pies is cut into 8 pieces, and we want 11 of those. So here's 1, here's 2, here's 3, here's 4, here's 5, 6, 7, 8, but we want 11, 9, 10, and 11. So we would shade in 11 pieces there. So this is the same as 1 and 3/8. All right, on this one, we're going to rewrite the improper fraction of 11/6 as a mixed number. So that means I want 11 pieces out of each of these circles that is cut into 6 equal parts. So there's 6 of them. Now I want 5 more. 2, 3, 4, 5. So this is 1, and then this right here is 5/6. That's your mixed number. Okay, so this page, it says use a model to rewrite the mixed number 1 and 4/5 as an improper fraction. So 1 means I color in every single piece of one whole circle. And then the 4/5 parts means that I color in only 4 out of 5 of these pieces. So this can be written as 1, 2, 3, 4, 5, 6, 7, 8, 9 fifths. Okay, so if I want to convert 11/6 to a mixed number, I've got 11/6. You ask yourself, how many times will 6 go into 11 without going over? It will go in 1 time, and what is my remainder? My remainder is 5, and your denominator doesn't change. The other way to look at this is 11 divided by 6. 6 will go into 11 one time. 1 times 6 using long division. 6, you subtract 5. This is your remainder right here. 5 is your remainder. We used to say R5. But now that we know fractions, this is actually 1 and 5/6. Put your remainder over however many pieces you're cutting the pie into. Okay, on this one, if I'm converting 33/8 to a mixed number, that's the same as 33 divided by 8. How many times will 8 go into 33 without going over? It goes in 4 times. 4 times 8 is 32. You subtract. And your remainder is 1. So you put this 1 over your 8. 4 and 1/8. Okay, so I want to convert 4 and 2/3 into an improper fraction. The fast way to do that is you take the denominator times your unit number, 3 times 4, and then you add your numerator to it. So 3 times 4 is 12, plus 2 is 14, and I've been saying all along we do not change our denominator. Okay, let's convert 10 and 2/7 into an improper fraction. You do 7 times 10 plus your numerator. So denominator times your units plus your numerator. So 7 times 10 is 70 plus 2. Our new numerator is 72. We do not change our denominator. 72/7. Okay, so equivalent fractions are fractions that have the same value. So if I had something that's cut into 2 pieces and I take half of it, that is the same as, this right here is 1/2, right? So now I'm going to cut it into 4 pieces, and I'm still going to take half of it. So now I've taken 2 out of 4. So the equivalent fraction here, 1/2, is equal to 2/4. Another thing you could do, another equivalent fraction to 1/2 would be 3 out of 6, 4 out of 8. We could keep doing this all day long. Okay, so on part A it says how many 8ths equal 1/2. So I want something over 8 is equal to 1/2. What do you have to multiply 2 by to get it to be 8? You have to multiply times 4, right? So you have to multiply the top times 4. So 1 times 4 is 4. So there are 4/8 that are equal to 1/2. Part B says how many tenths equal 1/2. So 1/2 is equal to how many out of 10. So I had to multiply the 2 by 5 to get it to be 10, so I have to do the same to the top. So I get that 1 times 5 is 5. So there are 5/10 equal to 1/2. Part C says how many twelfths are equal to 1/2. So I've got 1/2 is equal to how many twelfths. What did I have to multiply by? I had to multiply by 6. So I have to multiply the top by 6 as well. And I get 6/12. Okay, so this is just stating what we did in that last problem. Whatever you multiply the bottom by, you have to multiply the top by. Okay, find 3 fractions equivalent to 2/5. This is where every person in our classroom could get different answers, and everybody still be correct. So if I want to find 3 equivalent fractions to 2/5, I just multiply the top and the bottom by the same number. So you get to pick a number. I'm just going to pick the number 2. I just pulled it out of the air. So I'm going to multiply by 2 on top and on bottom. And I get 2 times 2 is, I don't know where that line came from. 2 times 2 is 4. 5 times 2 is 10. So 2/5 is equal to 4/10. Let's find another one. So I've got 2/5 is equal to, let's pick another number. Let's pick maybe 10. We could multiply top and bottom by 10. So whenever I multiply the top by 10, I get 20. When I multiply the bottom by 10, I get 50. So 20/50 is equal to 2/5. Let's find one more. So I've got 2/5 is equal to, pick another number, let's say 8. So I'm going to multiply the top by 8, and I'm going to multiply the bottom by 8. So whenever I multiply the top by 8, I get 16. When I multiply the bottom by 8, I get 40. So right here, these 3 fractions are all equivalent to 2/5. Okay, this says find a fraction with a denominator of 21 that is equivalent to 2/7. So I've got 2/7 and I want the denominator to be 21. Well, what did I have to multiply 7 by to get it to be 21? I had to multiply it by 3. So I have to multiply the top by 3 as well. 2 times 3 is 6. So 6/21 is equal to 2/7. Okay, this question says to locate and label the following on a number line. Okay, 3/4, that is not quite 1. So if I were to label that and locate it on the number line, it's almost a 1, but not quite. It's halfway between 1/2 and 1. So 3/4 would be approximately right there. Now 4/3. 4/3 is the same as 1 and 1/3. So it's not quite 1 and 1/2, but it's about right there, just past the 1. 5/3 is the same thing as 1 and 2/3, so not quite 2. So it would be about right there. 4 and 1/5 is just slightly past 4. And 7/2 is the same thing as 3 and 1/2. So about right there. So it's easier to turn improper fractions into mixed numbers and then plot them on a number line than to try to figure out where they are as improper fractions.